Okay. Assalamualaikum and good morning. Today we are going to continue the topic of kinematic of particles. Okay, and the specific topic that we are discussing is the topic of dependent motion of particles. Okay, so we're going to start with a one degree of freedom. Okay, 1 degree of freedom, or some people say single degree of freedom. Okay. So 1 degree of freedom. Okay. So for case number one, for this case, we have, if you see this figure, okay, this figure, what you can see is the pulley. Okay, we have pulley and we have blocks. Okay, we have pulley, we have blocks. Okay, so this system has 1 degree of freedom system. 1 degree of freedom. Okay, since at any time instant only one coordinate can be chosen arbitrarily. Okay, so what does it mean is one motion of the block will depend on the other block. So motion of one block will depend on the motion of other block. Okay, so if you see this figure, we call this figure is dependent motion. Okay, dependent motion. Okay, so we have dependent motion. We observe that if you look at here, the total length, okay, we have here the string, the rope or the string, we call. So this total length of this string all together go here, go to B, and then going up. We have pulley here, 1, 2, 3 pulley, and we have the total length, okay, of the wire or the cable. We can write SA, okay, plus, okay, how many B? 1B, 1B, we cut the rope, 1, 2, 3, so we have 3B, 3SB equal to the total length, okay, total length of the cable. So this length of the cable is constant, okay, okay, that's how we write. Okay, we have one SA. From here we have to choose the datum. Okay, so we have the datum. Okay, and then we take going down is positive, so this is SA. Okay, measured from the datum to this location. Same thing to here. So we have SB measured from this datum to the center of the pulley. Okay, so for this equation, so I name this equation as equation 1.1. Okay, next we proceed with initial condition of block. Okay, initial condition of the block which are constant. Okay, so before this we know that the previous equation that we have, okay, SA minus SA dot. Okay, so this is what we sometimes we say delta S. Okay, delta SA, and then this is delta S. Okay, so delta mean we find the difference between SA to initial position of the block, whether either it is block A or block B. Okay, we can observe. Okay, this is our observation. The thinking part is here. Thinking part. Okay. Okay, what happened if A is increased Okay, A is increased. So A is increased from SA to delta SA. So we have the increment, okay, the displacement from one position to another position. Okay, so we have it over here as SA, and then we have the increment, small increment in delta SA. Okay, and then the effect of it, okay, the effect of it is going to be, so we have to solve this equation. Okay, so it's going to be delta SA, delta SB. Okay, since here is delta SB is going to have minus SA divided by 3, right? So you bring the minus SA minus 1/3. So the delta part will follow through. So we have delta SB is equal to minus 1/3 delta SA. Okay, which is if block A is lowered at any amount going down at any amount of delta SA. Okay, so what we can see here, block B will rise. Okay, for negative, one go down and one go up, right? So block A goes down and block B will go up, right? So they are going to have to follow the equation 1.1 relation. Okay, so if block A lowered by amount of delta S A, block B will rise by 1/3 of that amount. Okay, and then when we have S, we can proceed to take the time derivative. Okay, time derivative to find the velocity, and then we can find acceleration. Okay, so we differentiate with respect to time. Okay, can differentiate with respect to time. All right, so we differentiate this SA plus 3SB equal to constant. So differentiate with respect to time, SA plus 3SB equal to a constant. So you differentiate with respect to time. Okay, all of this. So you differentiate S, you get VA. Differentiate 3SB, you get 3VB. You differentiate constant, you get 0. Right? And then you proceed to find another time derivative. Okay, it will give you the acceleration, and then you're going to get acceleration of A plus 3 acceleration B equal to 0. Okay, so this is the basic concept of a dependent motion. Okay, now we proceed to another one, which is a 2 degree of freedom system. Okay, just now is 1 degree of freedom system. Now is 2. Okay, 2 degree. Okay, so again, same thing. We have motion of pulley and blocks. We have pulley, block, we have datum. Okay, and then you can see here, you can draw the line, straight line here in the middle of this pulley, and then you can draw, okay, different S for these 3 blocks, A, B, and C. Okay, so you write as A, and then from to B here, Okay, this is SB, and then this is SC. Okay. Okay, so we have here 2-degree system with two coordinates. Okay, two coordinates or motion can be chosen arbitrarily. Okay, so how to write this expression? Okay, so we can write this expression, okay, in terms of the position coordinate of the block. Okay, so we can write as A. Okay, as A, how many S? 1S. Okay, so you can see how many you have two string, right? 2SB. Okay, and then plus SC equal to constant. Okay, the total length of the string. Okay, so you can have a same initial condition of the block, which is constant. So we can have here delta SA, delta SB. Okay, this is delta SC equal to 0 for initial position. Okay, and then same thing follow. We differentiate this equation 1.5, differentiate with respect to time. Okay, to get velocity, and then you do another differentiation. Okay, another differentiation, you get acceleration. Okay, which is what you have here, equation 1.7 and 1.8. Okay, so by having this, it allows us to analyze the motion of any block, right? Knowing the motion of the other two blocks. Okay, all right, this is 2 degrees of freedom. We start to do example, okay, to make the concept clearer. Topic of dependent motion. In your note, I think you make a correction, spelling, typo error. This is correct lah. I have corrected it. Kinematics, kinetic of particle. Okay. So we take this as an example. Example 1.1. Okay. So we have the system of mass and pulley. They are connected. So given that the block, which is initially at rest, they are not moving at rest, they are at rest. Okay, initially at rest is moving downwards. Okay, with a constant acceleration. These are the information given. In the problem. This block, okay, is given initially at rest is moving downward. Okay, with constant acceleration for meter per second. Okay. Okay, so what you need to do, we find acceleration of block A. Okay, acceleration of block A. Okay, find acceleration of block A. Number 2, find the velocity of block A. Okay, and then number 3, what will be the time it takes to displace 200 millimeter from its initial position. Okay, how long? The value of S. Okay, to displace, it displays 200 millimeter from initial position. Okay, so go down, so block A will go up. Okay, block B go down, block A will. Okay, so what is the distance traveled by block B after 3 seconds? Okay, these are the question that we need to solve. Okay, distance travel. Okay, okay. Okay, the thinking part. I want you to, okay, try to think about it. Okay. Okay. Get the acceleration. We relate with the theory first. Okay. So first thing, when you look at this type of problem, this is the simplest one, because later on we're going to start gradually to increase the complexity of it. So going down, we take the first thing. This is the first thing. Okay. We take going down is a positive direction. Okay. Okay. So the total length of the cable in terms of position coordinate of the two blocks. Okay. So we have we cut the string. So we have 2SA plus SB equal to constant. Okay, this is a constant. And then you proceed with next one to differentiate equation 1. Okay, twice. Okay, differentiate equation 1 twice. So you differentiate, you get 2BA plus BB equal to 0. Then 2AA plus AB equal to 0. Now, to start for the first one, we substitute A equal to 4 meter per second square. We substitute into equation 3. Okay, so once you substitute, the value of solution is 4. So 4, okay, so you get acceleration of A is going to be minus 4 divided by 2. So you get 2 meter per second square. Okay. Okay. So the opposite direction. Opposite direction. So this is AB going down. So acceleration of A goes up. Yeah, going up with the acceleration of 2 meter per second square. Okay. Okay. Any questions so far? Before we proceed to the next one.
No, bro. No, sir. No problem.
Alright.
Prof, nak tanya, kalau macam acceleration ni kan, macam ni kita nak tahu kita macam kena letak negatif 2J ke macam tu.
Negatif 2J. Ada J ke kat sini? Belum, tak ada J kan?
Macam mana nak tahu kita letak benda tu ke tak?
Oh, negatif 2J. So far not yet lah. So far we are dealing with only with the system without unit vector yet. This one we are dealing with dependent motion. Maybe you have a specific example. Maybe we can look. But as for now, we are dealing with the data. We set the data. This is 2D. Okay, 2D. So we are dealing only with a single degree of freedom and 1 degree of freedom without INJ yet.
Alright, Prof.
So we proceed to next one. Since the block, the acceleration is constant. Okay. So when we have the constant acceleration, okay, so we can use a uniformly accelerated motion. Okay. And then we can use this equation. This equation we can apply when acceleration is constant. Okay. Okay. So be mindful of the word acceleration constant. Okay. So you can use this. So block A and B will undergo uniformly accelerated motion. Okay. So I analyze this. You can see it. All right. So since the block starts at rest, okay, meaning initial velocity, okay, is 0. Okay. Okay. So we can use equation 4. Okay. We have S A equal to SA plus V A T plus half A T square. So V equal to V A dot plus A T and B square plus V dot A square plus 2 A delta S. Okay. So we have here, we use equation 4. Okay. Based on the information given. Okay. So we have S A, okay, since V dot is goes to 0, right? So the remaining part is only delta S. Okay. So delta S here, which is SA minus SA initial, okay, so equal to this equation, half A AT by, okay. So this one we have obtained just now, okay, the value, and then delta S is minus 0.2 meter. This is given in the problem statement. Okay. Nampak? The time it displays 200 millimeter from its initial position. Itu maksudnya. So you have 200 millimeter. Okay. So delta S is 200 minus 0.2 millimeter. So you substitute into equation 6 and 7. Okay, the value. Okay, the value you substitute into these two equations. Okay, so try to use your calculator. What do you get with the given information? Okay, so delta S half A T square. Okay, okay. And then is it correct that the answer for VA?
Yes, bro.
Please check.
Yes, doctor.
Okay. Okay, now we have obtained VA. Okay. And then we have obtained the value of T. Okay, in second. Okay. Based on the constant acceleration that equation that we have. Okay. And then we move to part C. Again, for part C, same thing. We need to find what will be for delta SB. Okay, so we're going to use the same uniformly accelerated motions equation. Okay, so we substitute the value and the same period, which is 3 seconds. Okay, part B, what distance is the distance travel after 3 seconds? So you substitute the value of 3 seconds there. Okay, 3 seconds into equation 8. Okay, yeah. Okay, so you get delta B equal to 3 meter. Basically, same thing, same way as we did in part B. Okay. So this is another question that you need to answer. Okay, within the same period of 3 seconds, how far has the block moved? Block A moved. Okay, and in which direction? Okay, so that is the thinking part. Okay. Okay. Now it's 10:36. We do another example. Okay. Another example. This is combination of the theory of relative motion. Okay. Relative motion. Still remember. Okay. So we have a block motion of block A. Motion of block A is controlled by the slider B on a horizontal guide using a cable. Okay. Okay. So we have this block is controlled by the slider. So we have slider B. Okay. Horizontal guide. Okay. Horizontal guide using a cable. Okay. Using a cable. So the question, find if at a certain instant the slider is moving to the right. Okay. Slider move to the right. Okay. At 0.6 meter per second. Okay. And then it is slowing down. Okay. Slowing down. So the acceleration and decrease. Slowing down at 1.5 meter per second square. Okay. So you need to find the velocity and acceleration of block A, and then what will be the velocity and acceleration of slider B relative to A. Okay. So we need to find velocity of B relative to A, and then acceleration of B relative to A. Okay. So that's why you need to recall the theory of that you have learned before, which is relative motion. Okay. B relative to A, B minus A, acceleration of B relative to A. Okay. All right. So first thing, in order for us to solve this problem, we need to choose the datum. Okay. Choose the datum. We can choose the datum which is is the process of doing the solution. Okay. Take 0 as the origin. Okay. Okay, we take this O as origin, and can introduce, we want to introduce the distance, the distance of A and distance of B. Okay, so from here to here, so we're going to introduce this. From here to here, we introduce this distance B. Okay, and then from here to here, right? From here to here, because the slider it move, not it's not stay there forever. It move right here, back, this, okay, to the right and to the left. So it's going to move XB. Okay, and then we have here X A. Okay, Okay, so try to think about it. Okay, I give you 5 minutes to figure this out, how to solve this. Okay, we continue at 10:45. Okay. Okay, you got it? Any question?
Why 2b minus xa?
2b minus
Xa.
2b minus xa. Okay, cable lah. So how many cable tied to block A?
One.
One. If you cut here, how many cable? Xb minus xa plus 2b 2 times b minus xa equal to L. Okay. So any other input from all of you? Look at this figure, okay? We cut this one, okay? Because we want to see how many the related to make it easier, we rotate. Oh, you can rotate here. You can see clearly. Okay. If we put 2 means we have to related root there. Okay. Okay, how do you look at it? Any other input from others?
Prof.
Yeah. Go ahead.
Is it because the 2B minus XA is because the pulley have the 2 wire?
Yeah, that's what I'm saying. Because earlier, what we have earlier is like that. Okay, from the earlier concept. Okay. You see, we have A kan. We cut here, and then we have 2 SA there. Okay. We cut the string. Remember, like a scissor, we cut these 2 strings, so it have two wire there, 2 string there. Same thing with here. Okay. Same thing with here. We have at B. You like a scissor, you cut this string. So over here you have 2 wire shared by this block. Yeah, same thing with here. Okay. For SB, for here we have how many? 3. For block B we have 3. 1, 2, 3. So for this case, okay, for this case, so when you cut, so how many string do you have there? Which is related to block A? 2, right?
2. 2.
Yes, 2.
Yeah.
2.
So we define the position. Okay, we write the cable length. So this is very critical, this one, as I mentioned. Okay, so this is very important. Okay, so we have XB minus XA. Okay, XB minus XA. And then the one related to the block, which is 2. We have this B, this B minus XA equal to L. And then you solve. So it's going to be in term of XB minus 3XA equal to L minus 2B. Okay, equal to constant. And then the rest will follow like what we did earlier. Okay, what we did earlier. Then you differentiate. Okay, XB, X differentiate, you get velocity, and then acceleration. Okay. Then for part B, okay, look at here, note velocity 0.6 and acceleration 1.5 to the left because it's decelerating. Okay, you can proceed, finish this, and then we take a break. Then we can to continue our lecture at 11. Okay.
Right.